So in this lecture, the next topic is acceleration, right? What is the acceleration? Acceleration is a vector quantity. Again, the acceleration is defined in two ways, right? The average acceleration and the instantaneous acceleration, right? Instantaneous acceleration. For example, suppose we have the particle, right? Its initial velocity is what? Suppose initial position is this. It starts with initial velocity vector v1 at time t1, right? It is at t1. Now it is moving and it reaches to the point B, all right? And its velocity vector become v2, right, at time t2. So what is the total time? Total time is delta t is equal to t2 minus t1. So how the average acceleration is defined? The average acceleration, which is the vector quantity, is nothing but change in velocity divided by total time, right? So initial velocity is v1, final velocity is v2. So what is the change in velocity? Delta v upon delta t, that is v2 minus v1 upon t2 minus t1. So this is define the average acceleration. Is it clear or not? Definitely it is a vector quantity, right? The SI unit is what? SI unit is meter per second square, and CGS unit is centimeter per second square, right? And it is a vector quantity. The direction of the acceleration, average acceleration, is same as that of the change in velocity. Direction of average acceleration is same as that of change in velocity, right? Because it is a change in velocity. This is the definition of the average acceleration, right? But listen one thing. Suppose the initial speed is 10 km per hour. You are driving a car, and after some time it becomes 50 km per hour. Whenever you are asked to find the average is asked between the two time interval, all right? And what is the instantaneous mean? For example, at this point, when you accelerate your bike or the car, so at this instant, by what rate the velocity is changing, that is called the instantaneous acceleration. So second acceleration is, right, instantaneous acceleration. The rate of change of velocity at a particular instant is called the instantaneous acceleration. I am writing the rate of change of velocity at particular instant of time, is called, right, instantaneous acceleration, right? Instantaneous acceleration. And mathematically, how do we define? At instantaneous acceleration mean the t1 and t2 times are very near to each other, right? That is delta t tending to 0, not equal to 0. When delta t tending to 0, the elemental change is converted, the small change is converted into elemental change, and the delta v converted into dv. Therefore, mathematically, we define the delta v upon delta t become dv upon dt, right? If limit delta t tending to 0, this is called the instantaneous acceleration. So the instantaneous acceleration is defined as dv upon dt, right? Simply we write it dv upon dt. That is the differentiation of velocity with respect to time give the acceleration. Again, it is a vector quantity, no doubt, and SI unit is meter per second square. The CGS unit is centimeter per second square, right? Copy this. So read this question. In this question, the velocity of the particle is given as the velocity as a function of time t, 2t square minus 4t plus 3, right? And its acceleration at 2 seconds. Listen, I'm extended the question. The first part, find acceleration at t is equal to 2 seconds, right? Second, find average acceleration, right? Average acceleration between from t is equal to 0 to t2 is equal to 2 seconds. These are the two parts, suppose. So find acceleration at t is equal to 2 seconds mean, what does it mean? It means you have to find the acceleration at 2 seconds. Whenever the average acceleration is asked, they will give you the 2 time interval, right, or the time for the particular time interval. So to find the average instantaneous acceleration, what will you do? You first differentiate to find the instantaneous acceleration. So 2 into 2t minus 4, right? So the instantaneous acceleration is 4t minus 4 at t is equal to 2 seconds, right? The acceleration is nothing but 4. 8 minus 4 is equal to 4 meter per second square. Is it clear or not, you tell? Fine. So listen one thing. And what is the meaning of the average acceleration? For example, right, the average acceleration is maybe asked from t1 to t2. The t1 may be 1 second, 2 testing, t2 may be the other time. So here t1 is 0 and t2 is 2 seconds. Suppose this is the car. At t1 is equal to 0. When you will put t1 is equal to 0, what is the velocity? 0 minus 0 plus 3. 3 meter per second square. So this is the velocity v1 is equal to 3 meter per second. Fine. At particular instant. At t is equal to 2 seconds after some time, what is the velocity? How would you find? You will put t is equal to 2 over here. 2 into 2 square minus 4 into 2 plus 3. So this is 8, right? 8 minus 8 plus 3 is equal to 3 meter per second square, right? So again, the velocity is what? 0 and 2. Okay. So it is again the 3 meter per second, right? So what is the average acceleration? The average acceleration is nothing but v2 minus v1, t2 minus t1. 2 minus 0, 3 minus 3. So average acceleration from 0 to 2 seconds is 0. But at this particular instant, the instantaneous acceleration at this point at 2 seconds is what? 4 meter per second square. So this is the difference between the instantaneous acceleration and the average acceleration. You understand? Copy this. So read this question. In this question, position of the particle moving along the x-axis is given by at square plus bt plus c, and the value of a, b, c and are given 7 t square minus 2t plus 5. This is the position as a function of time t. So how to find the velocity? Say dx upon dt is equal to, right, 7 into 2t minus 2 into 1 plus 0. So velocity as a function of time t, 14t minus 2. And how to find the acceleration? Say dv upon dt. It's differentiate again, 14. So acceleration is 14 meter per second square and it is constant. That is, with time t, it is not changing. Is it clear or not? So now, what the first part? The A part. What is the A part? Velocity of the particle at 5 seconds. So this is the equation. At t is equal to 5 seconds. What is the velocity at 5 seconds? Right. Put t is equal to 5. 70 minus 2 is equal to 68 meter per second. This is the A part. What is the B part? The acceleration of the particle at t is equal to 5 seconds. So whether it is 1 second or 2 second, right, or 3 second, the acceleration is constant. It does not depends upon the time. So at 5 second, the acceleration is 14 meter per second square only. This is the thing. You understand or not? So this is the instantaneous velocity and instantaneous acceleration at 5 seconds. Is it clear? One more thing. Whenever the acceleration is constant, so it's a constant mean at every second, every time the acceleration is same. Its average value and instantaneous value will be the same if a given quantity is constant. For example, if a car is moving with velocity 3.5 meter per second with constant velocity, it means its instantaneous velocity is always 3.5 meter per second. But whenever you are finding the average velocity between the two time interval, so its average velocity will also be equal to 3.5 meter per second. Right, this is the one thing. Now we discuss the part C. The average velocity during the interval t1 is 0 second to t2 is 5 second. Is it clear or not, you tell? Average velocity. So how to find the average velocity? Can you tell me? Yes, total displacement divided by total time. That is x2 minus x1 upon t2 minus t1. So t1 and t2 we know 5 minus 0, right? So how to find the x1 and x2? With the help of this. So at t1 is equal to 0, listen one thing, suppose this is the car, right? At t1 is equal to 0, fine, t1 is equal to 0. When you will put t1 is equal to 0, what is the 0 value? 0, 0, right? 0 minus 0 plus 5, that is 5 meter. That is its position x1 is 5 meter. Its motion over here. So this is the 5 meter. The initial position is not at origin, rather the car starts its motion from x is equal to 5 meter, right? This is t1 is equal to 0, fine. And after some time, when it is moving at t2 is equal to 5, at 5, so I will put 7 into 5 square minus 2 into 5 plus 5. 25, 25 सत्ते 175 minus 10 plus 5, right? So this is 170 meter. It means after some time it is moving, right? And t2 is equal to 5 seconds. It continue to move and its position is what? Its position become 170 meter. Is it clear or not? This is the x1, this is the x2. So what is the displacement? You will say the displacement is nothing but total displacement from here to here. So how would you find the displacement? Final position minus initial position, final minus initial. 170 minus 5 is equal to 165 upon 5. So 33. 33 meter per second is the average velocity between t1 is equal to 0 to t2 is equal to 5 seconds. Is it clear or not? This is the thing. So this is the C part. And what about the D part? D part is average acceleration during the 0 to 5 seconds. So how to find the average acceleration? Is nothing but v2 minus v1 upon t2 minus t1. So t2 is 5, t1 is 0, fine. So v2 and v1 you have to find. This is the velocity, right? So at t is equal to 0, at t is equal to 0, what is the velocity? You will say 0 minus 2 is equal to minus 2 meter per second. At t is equal to 5 second, how would you write? 5, 14 into 5 minus 2 is equal to 68 meter per second. Is it clear or not? So this is the V2 and this is the V1, right? So I'm writing this side 5 minus 0, right? V2 is what? 68 minus 2. V2 minus V1. So how much it is? It is 70 upon 5. And how much it is? It is 14 meter per second square. So what is the average acceleration? Vrinda, average acceleration is 14 meter per second square. Although you have calculated the average acceleration by basic definition, but I would say that if the acceleration is constant, so instantaneous acceleration or the average acceleration value will always be same. So you need not to calculate. If the acceleration is constant, you may write for any particular time interval, the average acceleration is same as instantaneous acceleration, right? Copy this. So read this question. In this question, a particle move on a circular path, right? And the radius is 5 meter. Fine. So when it complete the half circle, suppose initially with the 5 meter per second, this is the velocity vector v1 in this direction, 5 meter per second. When it complete the half circle, so it reaches to this point and it becomes 5 meter per second in this direction. Suppose this is the x-axis and this is the y-axis, or you may assume over here, right? This is the y-axis. So what is this? Is the magnitude. The v1 and v2 magnitude are same, 5 meter per second. But v1 vector, if you want to write, this is along the j cap, meter per second, right? And v2 vector, you have to write is the minus 5 j cap. Is it clear or not, you tell? Fine. And with the constant, when it completes, so average acceleration, how to find the average acceleration, you tell? The average acceleration is nothing but the v2 minus v1 upon t2 minus t1. Change in velocity divided by the total time. Is it clear or not? So first, this is the initial point, this is the final point. How to find the total time? Listen one thing. What is this semicircle? Say pi r. So what is the speed by which it is covering this semicircle? Say 5 meter per second. Because at every point the speed is what? Say 5 meter per second. Is it clear or not? So s is equal to ut, or time we can find the distance upon the speed. What is the distance it cover? Say pi r. By what speed it is covering? Say 5 meter per second. So pi into radius is what? Say 5 upon 5. It is cancel out. So pi. So what is the total time? From here to here, the total time taken is pi second. Is it clear or not? And what is the velocity? The v2 vector is what? This is the v2 vector. Fine. This is the v2 vector. Minus 5 j cap minus v1 5 j cap divided by total time, say pi. So minus 10 j cap upon pi. So the average acceleration is minus 10 upon pi j cap meter per second square, right? This is the average acceleration in the vector form. But generally you will see if they have given the answer only the magnitude. So when you will take the magnitude 10 upon pi j cap, this minus become positive 10 upon pi, and the unit vector magnitude is 1, right? So what is the average acceleration? You will write finally 10 upon pi meter per second square in half revolution. Is it clear or not, you tell? Listen one thing. Suppose this is the first part, and in second part they are asking find average acceleration, right? Average acceleration in one complete revolution. In one complete revolution. Fine. So listen one thing. So what is the average acceleration? You will say the v2 vector minus v1 and the total time t2 minus t1. In half circle, the time is taken as the 5 second. In the complete circle, the time is taken will be 2 pi second. right? Listen one thing, when the particle start from here, its velocity vector is what? Say 5j cap. When it complete the circle, so again it reaches to this point, so what will be the v2 vector? Say 5j cap. You understand or not? So in complete circle, final velocity is 5j cap in this direction, initial velocity is also the 5j cap, there is no change in velocity, so the average acceleration is 0 in this case. You understand how do we calculate? Copy this. So read this question. In this question, a particle is moving along the line OX. OX means, suppose this is the O for origin, this is the x-axis. At a time t, the displacement of the particle is given by x is equal to 10 plus 60 minus 3t square. Is it clear? How would particle travel before coming to rest? So if this is the x, so dx upon dt give the velocity, right, minus 60. So velocity as a function of time t is this. What do you think? Listen, at this is the x as a function of time t, right? So if you think, what is the x value at initially? At initially, that is at t is equal to 0, this is 0, 0. So it is 10 plus 0 minus 0. It is 10 meter. What does it mean? It means at t is equal to 0, the particle is not at x is equal to 0. Rather, it is at x is equal to 10 meter at t is equal to 0 second. You understand or not? This is the first thing. At t is equal to 0, at this point, what is the velocity? So 6 minus 0, 6 meter per second. That is its initial velocity at t is equal to 0 is 6 meter per second. Is it clear or not yet? Fine. This is the one thing. Now, if it is time is passing, right, the velocity is what? It is decreasing or increasing? In this case, it initially 6, then minus something. So velocity is continuously decreasing. It is 6, then decreasing, 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 and finally the velocity becomes 0. At what time, right, the velocity becomes 0? How would you find? Put velocity is equal to 0 and you are able to find the time. At t is equal to what? Say 1 second. So at t is equal to 1 second, its velocity become what? 0. Is it clear or not? Yes, Vrinda. At t is equal to 1 second, its velocity become 0. So in the question it is asked, how long would the particle travel? How long mean what distance it will travel before come to rest? So initially this is the x1 is equal to 10 meter. So at 1 second it comes to rest. So at 1 second you have to find the x2. So how to find the x2? Using this expression. All right. So this is the at t is equal to 1 second is the time when the particle come to rest. So this is 1 second. So x 1 second is equal to what? 10 plus 6 into 1 minus 3 into 1 square. 10 plus 6 minus 3 is equal to 13 meter. So this is the value of the x2. So this is the 13 meter. So initially 6 meter per second is the speed. Finally the speed becomes 0 at t is equal to 1 second. At this is the x1, this is the x2. So what is the displacement? So you may write over here, therefore the displacement, or you can say the distance travel before coming to rest is x2 minus x1. 13 minus 10 is equal to 3 meter. So this distance travel before coming to rest is 3 meter. Fine. Copy this. So read this question. In this question, the velocity of the particle moving the x direction is given as the v is equal to alpha root x. So this is the velocity as a function of x, not as a function of time t, right? At t is equal to 0, particle is at t is equal to 0, particle is at x is equal to 0, it is given. In the first part, they are asking time dependence of the velocity. That is the velocity as a function of time t you have to find. So how would you find? You will write v is equal to alpha root x. It may be written as dx upon dt is equal to alpha root x. Fine. So this is the dx upon root x is equal to alpha into dt. You understand or not? So first you have to find the x as a function of time t. So this is what? X raised to the power minus 1 by 2. Right. Dx is equal to alpha into dt. Now integrate. At t is equal to 0, the x value is 0. At t is equal to t, the value of x. So what is the differentiation of x ki power n? Sorry, integration of x ki power n is nothing but x ki power n plus 1 upon n plus 1. Therefore, x raised to the power minus 1 by 2 plus 1. Minus 1 by 2 plus 1. This is the formula. Right, and the limit varies from 0 to x. Alpha is constant, come out from the integration. The dt integration is t from 0 to t. Right, now you will simplify over this side. This is x minus 1 by 2 plus 1. This is 1 by 2 minus 1 by 2 plus 1. 1 by 2 is equal to, right, from 0 to x is equal to alpha. Put upper limit minus lower limit. Right, this is what? Root x and 2. 0 to x is equal to alpha t. So 2 root x minus 0 is equal to alpha t. Right. So what is the root x? Is equal to alpha t by 2. So you square this, alpha square t square by 4. So this is the x as a function of time t. Is it clear or not? So what they are asking in the first part, they are asking velocity as a function of time t. Velocity is what? Say dx upon dt. What is the x we have found? It is 1 by 4 alpha square into t square. So this alpha square by 4 as it is. And what is the differentiation of t square? Say 2t. So this is equal to 1 by 2 alpha square t. So this is nothing but velocity as a function of time t. Here the velocity as a function of x was given. First we have written the dx upon dt, then integrate, then found x as a function of time t. If x as a function of time t, then velocity is equal to what? Dx upon dt. Now how to find the acceleration as a function of time t is nothing but dv upon dt. Again, if you differentiate this, half alpha square into 1. So acceleration is what? Alpha square by 2, which is constant. Is it clear or not? So this is the acceleration, this is the velocity. Right, this is the first part only. First copy this. So this is the B part. The mean velocity you have to find over the time the particle cover the first s meter of the path. Suppose the particle or car, you can think this is the velocity of a particle as a function of time t. At t is equal to 0, the velocity is what? Say 0. Initial velocity is what? 0. So when it cover, this is the x is equal to 0. Now the x become s. How much distance it cover? Say suppose the s, first s meter distance it cover. So what time? It is the t is equal to 0. What time it will take when it cover the s distance? We can find using this. This is the x is equal to 1 by 4. This is the x as a function of t. So when the displacement become s, so what is the time? Tell me. The time is 4s upon alpha square is equal to, you have to take the square root. So this is 2 upon alpha root s. So this is the time. Right. So what is the time when the displacement become s? So put x is equal to s, the time you are able to find. So what is the time? So 2 upon alpha root s. At t1 is equal to 0, the displacement is 0. At t2 is equal to this time, the displacement become x. And what is asked in the question, please tell. In the question, mean velocity. The mean velocity mean the average velocity they are asking. So what is the average velocity formula? The average velocity is nothing but total displacement divided by total time. Right. So the total displacement is nothing but from here to here, s, and from here to here, what is the time? It is 0. This is total time is 2 upon alpha root s. Fine. If you simplify, alpha into s upon 2 root s, right? The s upon root s, alpha by 2, this is root s. So what is the average velocity or the mean velocity is alpha upon 2 root s as a function of x. This is the average velocity, right? Copy this. So read this question. In this question, a man walked 30 meters towards north. Listen, this is east, west, north, and this is south. All right. So starting point assumed to be the O, 30 meters towards north. Right. This is the O and A. This is 30 meters. Is it clear? And then 20 meters towards east. Then it turns, and this is what? How much it is? Say 20 meters. And this point is what? Say B. Now 30 root 2 towards southwest. What does it mean? East, west, north, south. What is the southwest direction, Vinda? Is between the southwest. And how much angle is this? You will say 45. 45. Is it clear or not? If this is the 30 root 2, this is how much? This is 30 root 2. Can you tell me the displacement in this direction is 30, in this direction also 30, then it will be 30 root 2 if it is 45. You understand this concept? Not understood. Listen. If this is x, this is x, so what is the diagonal? This is x, this is x, so x root 2 it will be or not? If it is x, it is x, it is x root 2. How? Suppose this is y, so y square is equal to x square plus x square is equal to 2x square. So y is equal to what? Root 2 into x, right? Or you can assume root 2x square is equal to x root 2. So if it is x, it is x. What is the value? Say x root 2. Or you can say if it is 45 degree. Is it clear? It is 45. If it is x root 2, so what is this distance? This is 30, this is 30, then it is 30 root 2. If this angle is 45 degree, you understand or not? So now at this point, what is the southwest direction? This is the south, this is the west. So southwest direction it will be or not, you tell. 45 degree. Tell me. Right? This is the southwest direction. And how much he has to travel? Say 30 root 2. When it will move 30 root 2? You tell. Give me 1 minute. Hello? है? अच्छा और बच्चे गए? अच्छा ठीक है okay, so listen one thing. Now 30 root 2 kilometer southwest. 30 root 2 mean it has to travel in the 30 in this direction, right? And the 30 in this direction. Is it clear or not? If it is 30 in this direction, 30 in this direction, then only it will be covered as 30 root 2. So in the southwest direction from here, from the mid, right? This is 30, this is 30. So finally the particle reaches to this point. This is what? 30 root 2, right? It is 45. It is 45. Is it clear or not? Right. So this is 30, this is 10. So finally it reaches, and this is what? This is 20 meter, and this distance is how much? Say 30 meter. This is how much? Say 30 meter. This is how much? Say 30 meter. So therefore, if it is 20 meter and it is complete 30 meters, so finally O to A to B to C. This is the final position. How much distance it is? Say 10 meter. Right. So what is the, it is the initial point, it is the final point. Right. So this is the displacement. What is the displacement of the particle? Displacement is nothing but say 10 meter. In which direction it is? Towards west. You understand this thing or not, you tell? Should I explain once again? Tell me. Yes, that is the thing. Listen one thing. If this is the position somewhere of the particle, and in the southwest direction, mean at 45 degree, this is the west, this is the south, it has to travel 30 root 2. Suppose 50 root 2 it has to cover in this direction. If the particle is going in this direction, is it moving towards south? Yes. It is moving towards west? Yes. If it is southwest direction, it means if 45 and it is 50 root 2 suppose. So what is this distance? What is this displacement? You tell. This is the diagonal 50 root 2. So in south direction, yes, it is 50. And what is this displacement? Say 50. Right. So if the particle is at this point, right, and it has to travel the southwest direction, and how much? Say 30 root 2. So 30 root 2 mean it has to cover the 30 meter in this direction and the 30 meter in this direction. So what is the final position? You tell. The final position is this. This is 30, this is also 30, but this distance is given as the 30 meter and this distance is only 20 meter. So in this direction, the 10 more meter, right, more 10 meter, and final position is this, right. So this is the 10 meter final displacement. Is it clear or not? Not. This is the, this distance is 30 meter and this displacement is 30 root 2 along southwest. The angle is 45, right. So it has to cover the 30 meter in this direction, but if it covers the 30 meter in this direction, so it reaches to this point. 30 meter this direction, so it reaches to this point. So that is the final position is this. The 10 meter on the axis on the west direction, right. Okay, read this question. In this question, the body move along the curve path, right. This is the position, initial position. This is the initial position, and quarter circle mean it reached to this point from A to B. Fine. If this is the radius, this is the radius. What is the total circumference of the circle? Say 2 pi r. Half semicircle? Say pi r. What is the quarter circle? Say pi r by 2. So this is the path length. So what is the distance? You will say pi r by 2. Is it clear or not? And line joining initial to final position, this is what? Say displacement. So what will you say the displacement? Please tell. If this is r, this is r root 2r. So r root 2 you can say. What they are asking? Ratio. Ratio they are asking of the distance and displacement. right? So they are asking pi r by 2 and r root 2. R will cancel out. This is pi upon 2. This is root 2. So the value of the pi is 22 upon 7, 2 root 2. 7 root 2. So which option is the correct option? The third option. You can check the answer. So read this question. In this question, a drunkard is walking along a straight road. He takes 5 steps forward and 3 steps backward. So initially the drunkard is supposed to this, right? And 1 step is of 1 meter and 1 second it will take. Listen, 0, 1, 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10 and 11. So there is a pit, right? There is a pit at the 11 meter, right? 11 meter. You understand? This is 10, 9, 8, 7, 5, 4, 2, 3, 2 and 1 meter. You understand this or not? You tell. So according to this, 5 step forward. 5 step forward mean 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Then 3 step backward. 1, 2, 3. So from here it move like this and come back to this position. Is it clear or not? So how much time he take from here to here? 1, 2, 3, 4, 5, 6, 7, 8. So the 8 second he has taken from moving from here to here. Is it clear or not? Right. Then again 1, 2, 3, 4, 5. Right. And 3 step backward, 6, 7, 8. So again the person drunkard move to this point from here. So how much time take from here to here? Please tell. 8 more seconds and it reaches to this point. There is a pit. Then again, yes, listen one thing. 1, 2, 3, 4, 5. Fine. And then 1, 2, 3. Is it clear or not? So from here to here again, how much time it takes? 8 seconds. Listen one thing. When it reaches through this point, look carefully. 1, 2, 3, 4 and 5. And it goes into this. So how much more time it takes? 1 second, 2, 3, 4, 5. So he takes 5 more seconds. So the total time is what? 24 और 5, 29 seconds. You understand or not? Right, copy this. So read this question. It is S is equal to t cube minus 6t square plus 3t plus 4. So the velocity is what? ds upon dt is equal to 3t square minus 12t plus 3. Now the acceleration is what? 6t minus 12. So put acceleration is equal to 0. The t is equal to what? Say 2 seconds. At 2 seconds we have to find the velocity. We have to find the velocity when acceleration is 0. When the acceleration is 0, say t is equal to 2 seconds. So the velocity, it is a function of time t. So at t is equal to 2, 3 into 2 square minus 12 into 2 plus 3. 2 दूनी 4 12 minus 24 plus 3. So how much it is? 28. So it is not 3, rather minus 9 meter per second. You understand this question? Copy this. Little different. So read this question. In this question, the initial velocity of the particle is what? At t is equal to 0, the initial velocity is u. And the acceleration, which is represented by f. Acceleration is always not represented by a. Here, the f is the symbol for the acceleration is a. What is a? A is a constant. Like c is a constant. Here the a is a constant. So the acceleration is nothing but dv upon dt is equal to a into t. You understand or not? So now dv is equal to what? A into t dt. Is it clear? Now you have to integrate. The a is constant, t is equal to 0, the speed is u. At t is equal to t, the speed is v. So the v a t square by 2 from 0 to t. Is it clear? So v minus u is equal to a, right? T square by 2 minus 0. So v is equal to what? U plus half a t square. You understand this relation? Right, listen one thing. The student may ask like this: if this is the acceleration, this is the initial velocity, v is equal to a plus v is equal to u plus at. A is the acceleration, a is what? Say this is the a into t, u plus at square. So this is not the right solution. Are you getting or not? Yes, yes. So the student may be right this solution, but it is not correct. Why? Because this is the equation I will discuss. It is used when this acceleration is constant. Right? This is the equation of motion which will be used when the acceleration is constant. But here the acceleration is a function of time t. So whenever the acceleration is a function of time t, you have not to use this equation. You have to use the differentiation and integration like this. Understood? So this is the correct answer. This is not the correct. Copy this.